And then we say is continuous integration. Just try to cover here. The frequent integration and testing is to provide the frequent feedback. And why this is required, because if there are some change happening, some small changes, you don't want those kind of changes to sit idle. You should find a way to integrate this with the others. And in this physical systems, it is difficult to integrate continuously. The supplier, organization, and test environment practicalities need to be considered. But we should try to do this continuous integration, and as I show in the next slide, if the hardware is not available, there should be a kind of stubs or marks can be created. So if we say a system, a product involves a software as well as hardware, then in terms of software, there can be a development of this system to a staging and the production. But if the hardware is not available, it can be done in the virtual environment, where can be it can be simulation models or verifications can be done using stubs, or there is a concept of digital twin. So if say for automobile or for a car or autonomous car, if the actual hardware is not available, everything can be simulated, and then same features which are developed using a software, those can be tested in this simulation environment. And once the hardware is available, then it should be, say, physical world, enter into physical world, and should be manufactured and assembled and delivered into the production. But as we see, the software part, we can say the continuous integration, but it is continuous because even though we are testing it here on actual hardware, the behavior might be something different, but still it helps us to test a lot of things early in the time. Okay, so next is about the test driven. And if we know that in traditionally, in case of industrial organization, they follow a typical V model, and this V model is a traditional. And in this, what we do, we write a feature, or you can say the system requirements, and then write a story for a software requirement, then do the actual coding, and then the code is tested, and then software requirements are tested, and then functional requirements are tested. But the same thing, what we have a challenge with the waterfall model. Similarly, in the V model also, this kind of challenges are there. Then how should we overcome it? To overcome, I think there is quite a famous term now coming, shifting left for testing. So everything should be a test driven. So instead of waiting for this to develop and then do the testing, it can be write a feature test, behavior driven test, and then test the feature. Similarly, write a story or the software requirement should test this, and same thing for the code also, it should be tested. So if this is done early, and it really helps to improve the quality of the product. And as mentioned in the other slides, so if hardware is a challenge, then there are hardware proxies can be built early on and mature them over a time. For example, say 3D print parts and all. So this is the other way to represent it. In traditional testing, is mainly used to find the defects, where we have a small number of, say, individual unit tests, then some large number of component tests, and system level tests are a lot more. So what happens if we do for continuous integration using this method, then this will really slow down. If there are large, because it's a complex system, we do a large amount of, say, feature test, then it will really slow down. So instead of this, we should follow the agile testing, which is created mostly to prevent the defects. Where we at the early in the stage, there should be a lot of unit test case or individual component test case should be developed, and software should be tested very much early in the stage, which is small components tested for each in small component, and then this can be a fast approach, wherein for the component integration can be a medium, and then as we test a lot of functionality lower in this triangle, then the actual system level test can be a small, and which can be run much faster. The last principle is about addressing this compliance concern, and as we see in the other slide also, the very much first slide. So instead of if we talk about this industrial system, there are a lot of compliance from the government or the different agency that it should be functionally safe, security should be good, personal data compliance should be there. So if all this is done at the later in the stage and we find that, okay, security is not good or compliance is not working, then this could be a challenge and it may delay the overall development of the technical program. So to ensure that this compliance should be built in with the automation in terms of the CI/CD pipeline. So build in the compliance incrementally. So it should be there within the product, so that at the last, it does not mean that we don't do any, say, compliance testing and the security at the last. Before the release, it should be done, but that will be more comfortable testing where there will be less kind of issues or defects. This is the same is depicted here, that how we achieve it in case of agile release train. All the quality compliance testing in VNV teams should be added as part of the agile release train, and this should be inbuilt, and we should apply this continuous verification and validation, which will help to improve the product quality.